Hi, I am 07162338 Chen Yuwei. Today I'm going to talk about implementing mass and spring system with damping in MATLAB. We know that the equation of this system is mass times acceleration plus damping coefficients times velocity plus spring constant times the position. Here is the equation. In the equation, which parameters we can control are mass, damping coefficients, and spring constants. We control those parameters here. This line, 9. After we initialize those parameters, we put them into the equation. Line 15. Then we use ODE 45 help us to solve the second order ordinary differential equation. Line 17 here. Then we down and we plot the results. Figure 1 is about the position of the mass in this systems. Figure 2 is about the velocity of the mass in this systems. And figure 3 is an animation of this system. We can see how the mass moves in these systems. Now I will show you how damping coefficients influence the systems. In math computation, we know that if damping coefficient is smaller than 2 times roots of spring constant times the mass, we call this situation under damping. Equal to 2 times roots of spring constant times the mass, we call this situation is critically damping. And larger than 2 times roots of spring constant times the mass, we call this situation is over-damping. Now we first show under-damping. Our mass is 1 and our spring constant is also 1. So 2 times roots of spring constant times mass is 2. Under damping told us that damping coefficient will smaller than 2, so we initialize this 0.5, then run. You can see position of the mass is like this, like undamped, and velocity. Animation. Animation is about this. You can see this blue ball moves from 2 to here and then we show critically over-damping. So damping coefficient will equal to 2. You can see the animation of the system will be it will stop here at 0. And you can see the position of the mass will and velocity will go to 0. Then we show over-damping. Maybe we choose damping coefficient equal to 3. You can see the animation. It's like critically over damping, I thought.